All right, so for my example on collapsing some categories, I'm going to use this data set from one of my groups in my online class. So first and foremost, I don't know how I missed this, but you guys, this particular group, if you actually look at the number of clothes that people could buy, because they looked at how many clothes people spend, like how many items people buy per month and how much they spend per month on clothes, they left out everything between 7 and 11, which is strange, but that's okay. I should have noticed that. I don't know how that survey slipped through without me finding that particular error. But anyways, we've got 4 categories here, and we can see right now there's a really small number in the 11 plus and the 5 to 7 categories anyway. Most people are only buying 1 item or none, and then a lot of people are in that 2 to 4 item category. So my suggestion to this group would be, there's not really buying us anything, especially because we have this weird gap. Let's go ahead and create just 3 categories, the 0 to 1, the 2 to 4, and then 5 or more. So in order to do that, the easiest way in StatCrunch to do this would be to insert a column, and we're going to change this to whatever. I'm just making up a name. And then we're going to go to this column that we did the insert from, and I'm going to sort this. And it doesn't matter how I sort it. We said 2 to 4 was legit. That was fine. There was a number of people in that category. So I'm going to go ahead and leave the 2 to 4 alone. If I do Control C, I'm just going to copy the 2 to 4. What happened to all the rest of them? Oh, I'm just in the middle of it. I'm a maniac. All right, so I'm going to go ahead and I'm going to highlight all of the ones that fall into this 2 to 4 category. And I'm going to just paste. So everything is 2 to 4. Now 5 to 7, I said, was a pretty small group. I'm just going to do 5 plus for this section. And I'll do copy and paste. So those are all 5 plus. And I'm going to come over here and I'm going to change all of the 11 pluses also to 5 plus. Another advantage of this is if you notice with the bar plots, with the bar charts, and also with the pie charts, they tend to put these things in order based on the alphabet or numerals. And so the 11, as you can see, comes after 0 to 1 and before 2 to 4, which is kind of just doesn't make any sense. So I'm going to grab this 0 to 1 and also throw that in here up until that. So now if I come in here and I do a quick bar chart or a pie chart, doesn't matter which, and I do it on this new categorical variable that I've cleaned up, we can see we only have 3 categories, and this one at least has 7 in it. It's still going to be a problem for a lot of the chi-squared assumptions, because if I split 7 into 2 groups, I'm at 3.5, which won't get me the 5, but at least I am in this category. If you wanted to go even further and just do 0 to 1 and 2 or more, you could, and then you wouldn't have any assumptions violated in terms of your expected counts in a chi-squared. So same thing here, this group has a lot of different categories for the amount spent on clothes. And if we look at this really quick, I'll just do a pie chart. The amount spent on clothes. Again, lots and lots and lots of stuff going on. We only have 2 people in this 81 to 100 range, but it looks like, very few in the 120, a couple in this 150, this crazy range. But it looks like maybe a nice cutoff would be 60 or more, right? Like it looks like that would put us into some nice little categories here. I like things evenly spread out, so I like what they did here. So maybe less than 60, more than 60. Again, there's no right or wrong to this, like spending. But we could, again, just do a quick little sort this table here, make a little variable, and we could make a category that's just less than 60. And every group that's less than 60, we could throw into that category. And then we could have a more than 60 for the rest of them. I know that this is making our data a little less clean or a little less, informative, but at the same time, I mean, these cutoffs are a little bit arbitrary anyways, and I'm sure most people don't know exactly how much they're spending to that $20 mark, right? One more item would put me into the next category. So this might be a better sort of thing to think about here. So again, I could just do a quick pie chart to see what the breakdown looks like if I change that and I look at spending instead. And now I've got 16 versus 37. So maybe 60 was a good cutoff. If I want it to be a little more even, maybe I go with $40 as that cutoff. But I think this is pretty reasonable. And again, thinking through to chi-squared type stuff that we're going to be doing next for a lot of these groups, based on gender, based on the number of items they spent, bringing this down means that we're much more likely to hit that expected number of 5. So that's just a way to collapse your groups. If you have something that is categorical to collapse, so I worked on this earlier, one of the students from my 119X class was looking at the different types of jobs people had and how many hours they worked per week, which is an ANOVA situation. And again, when you have really small sample sizes, so for her, she had, and let me just do the summary stats. She had looked at hours working per week, grouping by the type of job they had. And you can see she actually got this little section here that says NaN, which is not a number. And that's because she only had one security guard. And so when it tried to create a standard deviation, it was dividing by, right, n-1, which is 0, and it came out as not a number. But this is going to cause issues. When she goes to do ANOVA, when you only have one person in a group, it's pretty easy to say, well, that group is different than another group. So we went through on hers, and just to give you guys an idea of what you can do, again, we sorted this stuff, and we made a separate job category that was like whether they were like a service worker, whether they were in construction, and people that didn't fall into any of these categories, we just left blank. And that's completely okay. This is to say I only want to compare these 3 different types of jobs: construction, office, and service. If you didn't fall into these 3, we just excluded you. Didn't delete their data. They're still there. But we did go ahead and not put in what their job was so that they wouldn't be included in our ANOVA and our box plots that we did later. So I just wanted to give you guys a way to deal with if you had a ordinal categorical, which means there is an ordering system. You can just kind of collapse things a bit. You can also do this with your quantitative if you want to divide people into 2 different age groups instead of looking at age as a quantitative. That's completely okay. And then if you're dealing with a categorical where you had lots and lots of levels, but it was nominal. Did I say ordinal before? I have no idea. But if you're dealing with something where there's no real ordering scheme, thinking about how you might collapse those into maybe, you could even done construction versus not construction, especially when you look at your first summary stats on this, right? Those stats I closed. You can see construction is one of our biggest groups, so is office, and they both have averages that are way higher than the rest. So you could say, like, I just want to look at office workers versus not office workers, or construction workers versus not construction workers. That's completely okay. Just make yourself a new category and go from there.